So today we're going to be doing injective, surjective and bijective functions. Okay, all right, so I've already pre-written some of the stuff on here to save a little bit of time. First of all, here is the domain, which is the set of input values. Here is the codomain, which is all the set of possible output values. An injective function, also known as a one-to-one function, is a function which maps each element of the domain onto a distinct element of the codomain. A surjective, also known as an onto function, every element in the codomain points to at least one element in the domain, and an important corollary of that is that the range, which is the actual values of the function, equals the codomain if it is surjective, and a bijective function basically is that it's injective and surjective. Okay, so let's give a couple of examples just to clarify this. So this is right. So let's imagine we have a function which maps 1 to A, and it maps 2 to B, and it maps 3 to C. Okay, this is injective because every single element of the domain is mapped onto a distinct element of the codomain. It is not surjective because the range of this function is A, B, and C, but the codomain is A, B, C, and D, so the range does not equal the codomain, so it is not surjective. Okay, so let's try another one. And what we're going to do in a minute is we're going to do 3 JEE main questions, but first of all, let's just go through these basic examples, because the JEE main ones, once you understand this, you should, be able to give them a good crack. Okay, so let's have a look at another example. Let's imagine we have this. 1 goes to A, 2 also goes to A, and 3 goes to C. This is not injective because each element of the domain does not map onto a distinct element of the codomain. 1 and 2 both map to A. Neither is it surjective because the range is A and C, and the codomain is A, B, C, and D. So it is neither injective nor surjective. Okay, let's have a look at a third example. Third example, let's map 1 to A, 2 to B, and let's add 4 and 5, make it a little bit more interesting. 3 to C, 3 to C, 4 to D, and say 5 to C as well. Okay, is it injective? No, because 3 and 5 are both mapping to C. Is it surjective? Yes, because the range A, B, C, and D is equal to the codomain. So because the range equals the codomain, this one is surjective. And let's just have a look at one more example. Let's have a look at one more example. Let's take this one. Let's add a 4 in there. 1 maps to A, 2 maps to C, 3 maps to B, and 4 maps to D. This is injective because each element of the domain maps onto a distinct element of the codomain. It is surjective because the range, A, B, C, D, equals the codomain, and therefore it is bijective. Okay, right, so now this is if it's like this form. What about if it's in graphical form? Let's have a look at that. So let's get a quick bit of a clear space here. Let's move back to a black pen. Okay, so if we're looking at a graph like this, and we have something like this, the test for an injective function is if a horizontal line intersects more than once, it is not injective. Now we can see clearly that any horizontal line that we draw here is going to only intersect once. Okay, the test for surjective is all horizontal lines have to intersect at least once. Okay, so let's imagine that, let's just get that horizontal line out of the way. This here, assuming that the codomain is here and the domain is here, well then this is both injective and surjective because any horizontal line drawn across will cross that line only once. But what about if, for example, the codomain is all of the reals and yet the range is only here? Well, clearly this is not surjective because we could draw a horizontal line down here and it wouldn't hit the function at least once, and we could draw a horizontal line up there and it wouldn't hit at least once. Furthermore, let's imagine that we had this function actually went like this, for example. Well then, this would not be injective, because if we drew a line across here, it hits at 2 points, which means that two values of x go to the same value of f of x, and it's not allowed to do that. It's only allowed to have one. So that's how you look if it is a function on a graph. Okay, so let's have a look at some actual questions now then. So this first question here is from the JEE Main, January 2024, Shift 1. Okay, so pause the video if you wish to try and do it. Okay, so the function f, which takes the domain, which is n minus the number 1, and the codomain is the natural numbers, is defined by f of n equals the highest prime factor of n. And basically what they're asking is this one-to-one and onto, one-to-one only, onto only, or neither one-to-one or onto. Okay, so well, anyway, let's have a look at the domain. So the domain is here. Well, the domain is going to be the natural numbers 2, 3, 4, 5, 6, 7, etc. And the codomain, let's have a look at the codomain. The codomain is all of the natural numbers. So that's including 1, 2, 3, 4, 5, 6, 7, etc., etc. Okay, so the function turns n, which is the domain, into the highest prime factor of n. Okay, so let's just write the prime factors here. So that's 2, this is the prime factors, 2 to the power 1, 3 to the power 1, 2 squared, 5 to the power 1, 2 to the power 1 times 3 to the power 1, and 7 to the power 1. They're the prime factors of all of the first 7 natural numbers. Okay, so what happens is that the function is mapping n to the highest prime factor of n. Okay, well, the highest prime factor of 2 is 2, so therefore 2 gets mapped to 2. Okay, the highest prime factor of sorry, that should be 3 there. The highest prime factor of 3 is 3, so clearly 3 gets mapped to 3. Okay, so far so good. Now what about 4? Well, the highest prime factor of 4 is 2, so that means that 4 gets mapped to 2. Okay, well, we can see immediately this is not injective, because 2 and 4 are both being mapped to 2, so it certainly isn't 1, 1. And in actual fact, we can see clearly that it's not going to be onto either, because the range of values is not going to include 1, and it certainly isn't going to include 4, because, for example, 4 is 2 squared, so 4 maps to 2. Nothing will map to 4, because 4 isn't a prime number. So we know that it's neither 1 on 1 or onto. Okay, let's go on with the next one. Here's the next question now. Pause the video if you wish to do it. Okay, so we got two functions here, f and g, both mapping the natural numbers minus the number 1 to the natural numbers. Be functions defined by f of a equals alpha, where alpha is the maximum of the powers of the primes such that p to the alpha divides a, and g of a is a plus 1 for all a contained in the natural numbers minus 1. Then the function f plus g is what? Okay, so again, let's draw our domain. So the domain is the natural numbers minus the number 1. That's 2, 3, 4, 5, 6, and 7. And let's draw our codomain. The codomain is all of the natural numbers. So that's 1, 2, 3, 4, 5, 6, 7, etc. And now let's just have a look at what actually this function does. So when a is basically 2, 3, 4, 5, 6, or 7, then the prime factors of that are 2 to the 1, 3 to the 1, 2 squared, 5 to the 1, 2 to the 1 times 3 to the 1, and 7 to the 1. So the function here, f of a equals alpha, where alpha is the maximum of the powers. Okay, so we have to look at the maximum of the powers. So f of a here is 1, 1, 2, 1, 1, 1. G of a is just a plus 1. Okay, so that's 3, 4, 5, 6, 7, 8. And so f plus g is going to be 4, 5, 7, 7, 8, 8. And so now we can do the mapping. So when a is 2, f plus g is 4. So 2 maps to 4. 3 maps to 5. 4 maps to 7. And 5 maps to 7, so we can clearly see it is not injective because 4 and 5 are both mapping to the same thing. And also it is not 1-on-1 because nothing will ever map to 1 or 2 or 3. Okay, so that's that question there. Now finally for the last question, JE main June 22 shift 2. Okay, so if you want to do that, pause the video. Okay, so f maps r to r is defined as f of x equals x minus 1, and g maps r minus the two numbers 1 and minus 1 to r, be g of x equals that, and what is the composite function f on g? Okay, so first of all we have to look, so if the domain is the reals, so basically the codomain is going to be the of the composite function is also going to be the reals, because g maps r minus that to r, and then g goes into f, and f maps the reals to the reals. So the codomain of f on g is going to be the reals. So let's first of all calculate what f on g is. Well, that equals basically f of g of x, which equals where's g? X squared minus 1, so that equals x squared over x squared minus 1 minus 1, which equals x squared minus 1 over x squared minus 1, which equals 1 over x squared minus 1. That is f on g. Okay, now we don't need to know how to graph this. We can see that this is an even function, which means that it is symmetrical around this axis here, which means that it is going to fail the horizontal line test for injectivity. Whatever it looks like, it's going to be symmetrical. So even if it looked like this, which it doesn't, but even if it looked like this, as it's symmetrical, it is going to fail that line. So we know that it is not 1-on-1, it's not injective. Now as for whether it is onto, we just have to prove that the range is or is not the same as the codomain. Well, we can see here that there is no value of x which gives an output of 0, because it's impossible to get an output of 0 there, and so therefore that we know that the range of this function does not include 0, and therefore the range is different from the codomain, because the codomain is the set of reals which does include 0. So in actual fact, again, this is neither 1-on-1 or onto. Now, just a matter of interest, not that you would need to draw this graph in an exam, but in actual fact it looks like this. So it looks like that, and that point there is minus 1, and then of course it's going to look like this here and this here. So where that point there is 1 and that point there is minus 1. So in actual fact, all of this area here will fail the horizontal line test for an onto function, and so it certainly isn't surjective or injective. Okay, well, I hope you found this useful. If you did, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.